If you've ever tried 3D printing a model and had errors or issues, you're not alone. After this tutorial, you'll be able to use 3ds Max and TyFlow to make any model super clean and watertight for 3D printing. Let's get into it. Hey everyone, this is Kyle, and today we're going to learn how to optimize our 3D models in 3ds Max for 3D printing. There's a whole lot of 3D going on. Okay, so there's a bunch of different ways to model stuff in 3ds Max, but a lot of the times that we receive models, let's say for instance if you're working with a client, the models that you receive might be from a completely different software and they want a 3D print of it. So there's a bunch of different ways to optimize your models for 3D printing, and when I mean optimize, I mean either bringing the poly count down really low, so the 3D printing software can process it and handle it, or is creating a watertight mesh, which we'll talk about what that means, and eliminating any non-manifold edges, which is a really big issue, right? And so we'll touch briefly on those three topics here in this video. So just first off the bat, if you're not completely sure about how to use 3ds Max at all, I definitely suggest watching my beginner's crash course to 3ds Max. I'll leave a link to that video in the description. And if you're not sure how to model stuff in Max, I do have a how to model anything course that you can watch as well. I'll leave links to those below. So anyway, let's get right into it. So there's all kinds of different 3D printing softwares out there, depending on what kind of 3D printer you have or that you have access to. I have a Raise 3D 3D printer that I have access to, and I use that very frequently for like sort of architectural, like 3D printing like small buildings, and all kinds of different little mechanical objects and stuff like that. And I also have access to a MakerBot as well. So both of those 3D printers have their own sort of respective software, but regardless of what software you use, or even if you use a 3D printing service like Shapeways, something like that, you need to follow particular guidelines in order to optimize your 3D models, right? Like I mentioned previously. So let's start from the bare bones here. So we'll just create a really simple model, and I'll show you what I'm talking about by a couple examples here. So if I just go ahead and create a box, and then I'm just going to copy this over, and I put these two things together like that, just really simple. I grab one box, I toss an edit poly modifier on there, and then I attach this other box to it, right? Now we have a single object, right? Now if we try to 3D print this, it's the 3D printer software, depending on which software you use, some of them operate a little differently. They might be able to figure this out, right? In most cases though, what this is going to cause is this is not technically a watertight mesh, right? There's a void in there. It's going to do something funny. So we'll check out, I'll show you what that means. So what I'll do here is I'm going to export this file as an STL. So click on where I want to save it to, and then we're going to choose stereolithographic STL. That's what most 3D printing softwares interpret and import. So what I'll do is I'll just name this test 1 and select OK, and I'm going to pop over to IdeaMaker. So I'll do is I'll import that test. Okay, so now we can see our little test model there, and we can scale it up if we want to, but this looks pretty good. So what I'll do is I'll just go ahead and click on Start Slicing, and there's a bunch of different options. These are all different depending on which 3D printing software you use, but I typically just stick with like the standard like PLA, layered prints that have layer height of 2 millimeters, 0.2 millimeters, and 2 shells. You can of course configure all of these settings and stuff, and like say for instance the MakerBot software is very similar to this. You can choose your infill and your support and stuff like that, and I've chosen to generate support on all, so we'll see what that gives us. So I'll click on OK, and I'll click on Slice. and then we'll click on preview. And then all I'm really interested in is showing you guys what happens here, right? So you can see when I scroll through the layers, it's generating all the support here, right? And then it gives us this little platform, but we wanted the two cubes to basically stick together, right? So if I scroll up here, you can see that there's a void there, and that's going to come out very strange in the 3D print. It's definitely not what we want, right? If you would try to 3D print this, it might work, right? But then it might be really fragile and it might break apart because it's not one solid continuous object. It's not a watertight mesh, right? So if I close preview, and what I'm going to do is I'm just going to go ahead and get rid of this. What this is telling us down here is there are 0 non-manifold edges, but it's technically not a watertight mesh, right? So I want to get rid of that. Now, I mentioned non-manifold edges, right? So I'll leave a link in the description below for Shapeways, this support blog that they have here, this post, that kind of goes into detail of what a non-manifold edge really means. And what they say here is non-manifold geometry is defined as any edge shared by more than 2 faces, right? So this is kind of like an example here of a non-manifold edge. And now 3ds Max is pretty efficient at not allowing you to model non-manifold edges. It won't let you bridge across 2 edges that already have a face, that's part of the mesh. So it won't let you do certain things, which is cool. But a lot of other softwares are not that smart. So like if you were to import a model from, say, SketchUp or from Rhino or something like that, there is a potential issue with non-manifold edges that can occur. Okay, so I just wanted to mention this. So this kind of thing can occur with your models, especially if you're importing them from different softwares that don't have the full sort of control that 3ds Max does with controlling non-manifold edges automatically. But regardless, it's just something to mention. So just keep in mind that you can't have non-manifold edges, and then our little demonstration there with the cubes, you don't want meshes that are not watertight or it's a single sort of solid, right? So, okay, so for what I'm going to do here, I'm going to detach this, and we're going to do this sort of right way, right? So now we have 2 objects here, and then if you remember from my how to model anything crash course, we did cover boolean operations. So what we can do is do compound objects. We could do either boolean or pro-boolean. We'll just go with pro-boolean. Pro-boolean, the only difference there is you can boolean multiple objects together, and I always use it. So we'll do operation to union, start picking, and I'll do move, and then just click on the other cube, right? And now what this does, if we turn on wireframe mode, you can tell that chopped out this chunk here, right? So now this is one solid object, right? And what I'll do is just to demonstrate this a little further, we'll go to export, and then I'll just overwrite this onto test 1, right? And then we'll jump back over to IdeaMaker and we'll import that test again, and we'll see what the difference looks like here. So we'll start slicing and we'll hit slice, and then we'll preview, and then we'll bring down our layers, and you can see exactly what the difference looks like. So we got our support material generating here, which is great. This is all infill, which we can control the density of that. We have our shells. Okay, cool. Bring it up here, and then look how much cleaner that looks. Now this is going to print as one solid object, right? It's exactly what we want. It's one solid object, has no manifold edges, is technically considered a watertight mesh, which is perfect, right? Okay, so that was just one example, right? We'll delete that. And now let's look at something a little bit more complex, right? So I will get rid of this little test here, and then I've imported a building. This is something that we typically come across. Let's say, for instance, if you're 3D printing something for a client, they reach out, they have a model that they created in Revit. If you're familiar with Revit, Revit likes to make geometry for every little component of your building, right? So like it can be kind of a mess sometimes. Revit is perfect for generating drawings, which is typically the ultimate goal of a 3D model in an environment like Revit. So it doesn't really Revit doesn't really care about optimization all that much when it comes to geometry. Same thing. So it also, this same thing can also happen with software like SketchUp or Rhino or something like that. So you might get a model like this if you have your own like sort of 3D printing business, or if you 3D print stuff regularly for clients or something like that. You might come across this. And so I'm going to cover a couple different approaches here, right? So from our previous example, when we had the two cubes that weren't Boolean together, we had that void in the middle. Well, this kind of thing happens all the time. So that was just a sort of precursor example to what I'm about to show you, right? So sometimes you might get a model like this, which this model in particular was modeled in Revit. If I go into the edit poly and I go into element mode, I can click on each one of these elements, and you can see that each one of these elements is basically, it's not Boolean, it's not part of a solid object. These are just individual little objects, right? Even these little mullions here, they're all individual little pieces. If I sent this to IdeaMaker, it would freak out and it would just make a complete mess of this. I'm not even going to try because I know it's going to do that, right? So, and like even all of these individual little these windows are separate little faces, like in the walls and stuff. So you can definitely tell that this was modeled in a software like Revit, because Revit does, per floor, it does walls. It doesn't create a solid surface. I mean, unless you create it manually like that, it'll create walls per level, right? So this is something that's it's kind of a pain to 3D print, right? So there's a couple different approaches to 3D printing something like this building, right? One is to remodel it and basically trace over the building, which I've done plenty of times in the past, which is a really big pain in the butt. Another approach is to attempt to Boolean all of these objects together, right? So these are all part of the one single editable poly. What you could do is individually grab each element, detach them all, and Boolean them together, which you can, there's a couple, I have a script that, will allow you to batch detach all of the objects, which comes in handy sometimes for buildings that don't have as many objects, right? But the third option, which is the best one, is to wrap the entire mesh, or wrap the entire building in a VDB mesh, right? We'll talk about what that means and what that looks like. Okay, so what I've done is I modeled the interior void of this, because the model just came with the facade, and the facade is like way too thin to just print on its own. So we wanted to give it a little bit more, some kind of support inside of it. It's going to have to generate support material inside of it anyway, so we might as well just give it, some kind of geometry to actually process, right? So, yeah, with this done, what we can do now is, obviously we're not, complete. We're not ready to print this thing. See these things right here? These are considered non-manifold edges. We have flipped normals on some of our faces. There's, like we saw before, there's a million little pieces and components to this thing. So we obviously can't print this yet, right? So what we're gonna have to do is process this. And one way we can do that is by using TyFlow. Now, TyFlow, I'll bring up the little page here. TyFlow does have a free version, and they have a paid version now, which is really, really powerful. If you're not completely familiar with TyFlow, it's a plugin for 3ds Max that you can do a lot of different simulations with, all kinds of different particle and physics simulations, and it's an exceptionally powerful little tool. Generally speaking, if you don't have any familiarity with this software, it's totally fine. We're going to be using one very small part of the plugin. So what you can do is you can download the free version for your particular version of 3ds Max. And then you can continue on with the tutorial. If you're interested in learning more about TyFlow, I have a bunch of TyFlow specific tutorials where I do all kinds of different simulations and stuff like that with it. So anyway, so once you have TyFlow downloaded and installed, what you can do is go ahead and create a TyFlow object. In your standard primitives, you could just go ahead and drag out a TyFlow object like that. And then what we'll do is open up the editor. So now we have our editor. I'll just drag this over here so you can see what we're dealing with. Okay, so now what we're going to do is we're going to bypass pretty much all of these, operators down here, and we're going to drag out a birth VDB event, right? we're going to set our initialization grid to something really high, right? So maybe like 1 foot, right? Just maybe even higher. Let's go like to 4 feet or something like that, because we don't want to blow up our computer, right? So what we'll do now is we'll do object to SDF, and what we're going to want to do is select all of our stuff, right? All of the facade element, the whole building object, and the the little interior parts, whatever you got, right? You can really throw anything at this, which is really powerful. I'm going to do add selected, right? And what that'll do is if I just reorder my elements here and I hide my building geometry, my layers, that'll wrap the entire building in a watertight mesh, right? And now what we can do is we can really play with this. If I turn on my edge faces and I go to birth VDB again, I can decrease my voxel size to like 1 foot, right? And you can start to tell we have much higher poly count on the mesh. So obviously this is not optimized. We'll do that later. But what we want to do is bring back a lot of that fidelity, because what we're really essentially doing with this tool is we are wrapping all of those individual little pieces, all those little elements that were in that original facade mesh in one single cohesive object, right? And that's going to make the 3D print go way more smoothly. So this is something that this is a method that I use all the time for wrapping really terrible geometry. So anyway, we'll kind of shrink this down a little bit further, and we can continue reducing this until it starts to look good, right? So we can do 0.5, and then the more you decrease this, the more fidelity you're going to get. But of course, you might have to do some waiting to get this to process, right? So we'll do even 0.1. Now this one might crush my computer.
5 minutes later.
Okay, so now we have a really super clean version of that original mesh, and this is going to be great for 3D printing, right? So what I can do now is hold on to your hats. What I'll do is turn on edge faces, and I'll show you the density of this mesh. This is incredibly dense, right? Super intensely dense. We definitely don't want to send this to the 3D printing software because it will crush itself. What we can do now is we can start to play with some other things. We could do a VDB filter. So we can filter it by mean. What that'll do is it'll smooth out all the little rough edges here and stuff like that. And the mean, we can switch the filter mode to something a little bit more clean. So typically mean or median works really well. So we'll wait for that to finish processing. That smoothed out all those edges, and it's looking pretty good. So I think I'll just keep it on mean, but you can always switch the filter mode to different filters here and see what works best for you. I found that like if you're trying to print something that's very organic, the Gaussian filter works really well. But if you're trying to print something that's very sharp edge, you want to maintain those sharp edges, either mean or median works the best. So we'll keep this at mean. And what I want to do now this thing is done and it's looking pretty good, is I want to go to tools and snapshot, right? I'm going to hit snapshot, and I'm just going to do a single snapshot as a mesh. Click OK, and that's going to create a mesh for me. And what I want to do here is I can right click in the canvas and I can go disable flow, so we don't need to see that anymore, right? But we still have our mesh that was saved for us, right? That's that yellow mesh right there, right? So what I can do is bring over my layer editor. I'll just grab this and I'll just stash it up here, and I'm going to call this building like baked or something, right? Doesn't really matter what you call it. And then I'm going to hide everything else. So I just have my baked building, and then this still has a ton of poly count, right? The poly count is super high. So we want to bring that poly count way down, right? So what I'm going to do is I'm going to toss on a Pro Optimizer modifier on this mesh, right? And what I'm going to do is I'm going to hit this calculate button, and it's going to take a while, right? So I'll just hit calculate. It's going to compute optimization, and it's going to optimize the mesh for us. And then we're going to use this tool to bring the vertex percentage way down. Okay. So I'm going to pause the video, and as soon as it's done computing optimization, we'll come back to it.
Many minutes later.
Okay. So the mesh is finally done optimizing. It only took about 5 minutes or so. Depending on the speed and power of your CPU, it might take a little longer. But anyway, so what I'll do here is this vertex percentage count, we're going to bring that way down to something like 5%, right? And what that's going to do, it might take a second to process. As soon as it's done, we'll do click on your edge faces here. We can see that it brought the poly count down poly count, excuse me, down quite significantly, right? We could bring that down even further, maybe something like 3%, right? And what I like to do is just turn off and on my edge faces and just kind of check the mesh out. And see, we start to get some artifacting here where there's like some strange normal stretching. You can barely see that, but it'll become much more aware if I bring this down to something like 2%, right? Or maybe like 1%. You see, when we start to see these normal stretching, this like artifacting that's going on here, that's not something that their 3D printing software is gonna like very much, right? So we want to try to minimize that as much as possible. We can get a nice clean mesh. So it's a sort of balance between optimizing the poly count and maintaining the integrity of the mesh that we're sending to the printer, right? So we can bring this back up to like 5%. That should be fine. So now this looks nice and clean. It's one single surface, not surface, but a single solid, right? And this is something that's like perfectly capable of being 3D printed now. So what I'll do is, what I need to do now is the last step is to flatten this as an editable poly, and so we can get ready to bring it over to IdeaMaker or your software of choice. Right click, and I'll do convert to editable poly. That'll just take a second. Okay, now we have a single object, and that's ready to go. Okay. Cool. So what I'll do now is with that selected, go to export, and then I'm going to name this building optimized. Right. Click on OK. And we'll head back over to IdeaMaker and go to import models and go to building optimized, and we'll go ahead and import that one. Just take just a second. And this is going to ask us in most 3D printing softwares, this is going to ask you the model size exceeds the printer's maximum build volume, apply auto scale. I typically say no and then scale it myself. So I'll go ahead and do that. Obviously this building is the size of a building, right? In most cases it will be, unless you scaled it previously. I did some scaling to this, but you don't really need to do that. What you can do now is just bring down the scale percentage, something like, I don't know, 5% or something like that. Maybe we'll bring that up a little bit higher. And you might want to actually apply actual like real world architectural scale units to your 3D prints, which I definitely recommend. So you can do a little bit of math on that to get like, 1 inch equals 30 feet or whatever scale you want it to be at, but you can do the little math and then put in your percentage there. So, all right, cool. So now with this imported, it's looking good. Doesn't look like we got any errors yet. We'll go ahead and do start slice. We'll stick with our standard settings there, just for demonstration purposes, right? And we'll just take a second here to slice it. Okay. Now this is going to take about 22 hours and 12 minutes. We can always bring down that estimated print time a little bit by optimizing the shells and the infill density and support and all that stuff a little bit even further. Okay, so then we'll go ahead and hit preview and check out the slice preview and see what we got. All right, great. So that's looking pretty good, and we'll bring down our layers and just to check this out. And this is looking just absolutely super clean, right? So we got our perfect support. I don't think there's any generated support in here. Maybe some on the windows right there. We have great layering happening there, and great infill density, exactly where we want it, right? Because we created a single mesh out of that whole thing. And the great thing about this method, by using TyFlow and the VDB tools, is you can just throw anything at it, right? So you don't even have to boolean stuff together, right? You could just throw a bunch of stuff at it and it'll just wrap everything you throw at it, which is awesome, right? Yeah, so that's pretty much the extent of this tutorial. I just wanted to share this, these couple different little methods with you guys, and hopefully this helps you if you're stuck troubleshooting how to get a model to print correctly. It saves so much time to just wrap everything in a VDB mesh, and it's super easy to use and very fast if you're using TyFlow. So if you have any questions, or if you're interested in seeing any more like 3D printing related topics, just feel free to leave a comment down below. Even if you liked the video, just feel free to leave a comment and let me know what you thought of it. If it helped you in any way, I'd love to hear that. Anyway, of course, if you like the video, hit the like button, and if you want to see more, subscribe. Of course, as a YouTuber, I got to say that or whatever, But anyway, thank you so much for sticking around, and hope you thought it was helpful, and we'll see you next time. Thanks.